Thank you. Thank you for staying with me with presentation, less presentation today in the summit. Just waiting 1 minute and I will start. My name is David Gyulnazaryan. I'm a co-founder of Impleon, which has been simple and open. My colleague Francois Tournesac are not able to be here for the reason of COVID, but I will deliver all the message which he wants. So, we will talk today about city swimming pool in Meudon. It is a suburb of Paris, luxury area. And the reason of developing heat reuse for that swimming pool is energy crisis in Europe. So the company which serve the 15 swimming pools around the Paris after this rise of the prices was not able to continue anymore support the swimming pools, and that swimming pools should go under the city municipality control. And they decide to look the opportunity how to continue in cost financial efficient way handling them. So they ask our company to evaluate the opportunity to make sustainable heating of the city swimming pool. And we start to evaluate what is there installed. So there was 3 gas boilers, each 900 kilowatt, 2 working, 1 reserve. And if you look for the temperatures for the pool is pretty low. So it gives opportunity to use low-grade heat for DataCenters, from servers. And another thing which we need to take into account, the yearly gas consumption, which we convert to the energy. And in this graph, we show that the energy consumption during the year is not constant. It has peaks and low demand. And we evaluate just 100 kilowatts IT boiler. And according to the graph, you see that it covers 51%, just 100 kilowatt. But at the same time, during the summer, there is like anti-peak, which is not allow run our IT equipment constant. For that reason, we evaluate the additional dry cooler, which will cover this low season and will make stable running all IT equipment. And this part is just 10% of overall energy consumption. Now, from point of view of the customer, there is many benchmarks. We compare the air-cooled modular data center as the source of the heat. We compare on-chip cooling racks with backdoors, immersion cooling, and integrated solutions like IT boiler, where is everything, servers, software, and etc. But for customer was important few things. First one is a building. It's a space which he provides inside of his swimming pool. If it is one rack, which is 100 kilowatt, it is very good for him. But if there is 100 square meters with a lot of equipment. It's another story at additional cost. And another thing that is there only cooling solution or also servers and also software and also cash flow, which will cover that energy consumption. So it's really hard to make turnkey solution. And the company which provide that all together and cover this energy consumption of the IT equipment and make that energy like for free. So the municipality was surprised that there exists such solution. However, there is many things which create this benchmark, and each solution have different score. So today we see that the prices last year rise up, after that come down, and what will be this winter, no one knows what will happen. It's unpredictable. For that reason, the return of investments is also depends from the prices of gas. But another thing, what happened in France, that if you want to renovate your gas boiler, you have no choice. You should take out and install something else, which not use fossil fuel. So this is happening right now. This is legislation. And evaluation overall about the France. So that center consume 3% of overall electric energy. And if we look for the swimming pools, there is 4,000 swimming pools, and according to this average consumption, 100,000 per swimming pool, there is a request for 40 million cubic meters of natural gas, which is a challenge. So, if we look what is happening now, we have data centers in France which use renewable energy mainly, and that all energy through the servers converted to the heat which is released to the environment, and swimming pools which use natural gas. And I want to introduce you to the term combined heat compute, which is mean heat reuse from the servers. And there is 3 options: air, on-chip, and immersion. And if we look for the air heat transfer, we have air coolers which provide low-grade heat, and in order to deliver to the right level, we use heat pumps, which is connect to the additional energy consumption and additional investments. If we look for the direct on-chip heat transfer, well-performed servers are able to use 80% directly from the chip, and the rest 20% as in the case which I explained before in previous slide. And the third one is immersion cooling, where 100% is already converted to the liquid, and that liquid is already ready for heat reuse for swimming pool. So in that case, we take away boiler houses and gas consumption. We not release our heat to the environment and make it useful. So this is how we make circular decarbonized economy. And if all data centers, not all swimming pools will use that approach of IT boilers, then we are able to save 760 metric tons of CO2 emissions, and the savings on fossil fuels is roughly 400 million euros. This is the potential of that transition. And call to action is to join to our immersion challenges workstream, heat reuse workstreams, modular data center workstream, and European workstream, where we talk about this heat reuse. Thank you for your attention. If there is questions, I will be happy to answer.
David, hi. Yeah. natural question is that you're using the compute to manage the heat loss from the swimming pool. So one of the issues I see with this is what happens if you've moved your boilers away from the equation. What happens when you replenish the swimming pool? How long will it take to heat the swimming pool? Do you need to have the boiler there anyway, just in case you need to do that? Because obviously the water that goes into the swimming pool will be at probably groundwater temperature. Engineering is all about compromises, yeah.
So in this case, which I show, there is supply and demand question, right? So I want to say that in this case, we still need gas boiler because during the peak time we use gas boiler because it's not 100%. But so it's combination. But we should look further how to make that 100%. So we should have more compute, and this gap when it will be not when will be no demand for the heating, it will be released to the environment. I answered on the question?
Yeah, it was more about the fact that if you have to change the water, empty the swimming pool, clean it, and then replenish it, you still need the gas boiler to bring the temperature up.
You mean overall?
Yeah, but this is really important because there's a data center in Stockholm that can only reject its heat to the district heating network between October and May.
Yes.
It has to do something else during those low times. So we need good solutions for maybe thermal storage.
Yes, so the point is that we are on the beginning of the story, and further we can improve that heavily. Find the right time for heating. Please.
Hi, David. I was wondering, do you have any correlation as far as 100 kilowatts worth of IT boiler, how much volume of water that can heat? Or do you have a correlation from the size of the volume of water to the heating load of the IT system?
Actually, yes. You on this graph, you see on the left side, it's energy. And during the months, you see how much energy it's provide. So it is in kilowatt hours. So this data exists. I can share with you.
Okay, but in regards to the kilowatt hours, pools are different sizes. They contain different volumes of water. Do you have any correlation to the volume of water needed to reject the heat?
Yes. So this swimming pool is Olympic size. Olympic size is mean 50 meters on 25. And most of the social swimming pools are the same. It's no matter France, UK, or US. They all use the same size. And this is the energy consumption for France. And if we take the country northern, it will be higher. If southern, it will be lower. But roughly 100,000 cubic meter of gas, roughly. Hi.
I just have a very quick question. I don't know if you talked about this, but there must be a communications outreach aspect to bring the municipalities in to explain this to them, just what was done in France anyway, and Lyon to get the municipalities to understand what you could do.
Yes, but if we talk about Europe, in France, in UK, in Germany, that swimming pool is like social, right? So they have real issue that or they will survive or they will be closed. So they understand that there is request to change thing, or otherwise they will be just closed.
Okay, so my quick question is there an outreach effort that has to happen to communicate with these social pools?
Well, actually, we don't do that. We just explained that through the community, different channels. But what I want to say, here is Stefan Frenzel. He can confirm that right now in Germany is accepted legislation that all data centers should make 10% of heat reuse, and that stimulate that process. But it stimulates to make heat reuse for the data centers, and I want to say that there should be another stimulation to stimulate district heating operators be connected to the data centers. So it's like men and women, they should want to be together.
I don't want to say anything now. Okay, but thank you very much.
Thank you. Thank you very much.